Ready?
Yeah.
So today I want to explode a pumpkin, but I want to do it in a way that is safe, but also awesome. So what we're going to do is we have to devise a way to explode this pumpkin in a somewhat safe way, because we're going to do it inside. So you're going to actually think about how we're going to do this. So what have we done so far that would generate an explosive gas? What do you think?
Water.
What is it?
Water.
Water and what? Water, just water, yeah. Because we could do electrolysis, and we could get, yeah, but what else? What have I already done? I haven't done really electrolysis in class. What is it? You can keep going.
I was going to say water and potassium.
Water and potassium. Now the potassium kind of just blew up. So maybe like the lithium, because the water in lithium didn't really catch on fire all on its own. Like it was a little bit less violent. So maybe I could use a piece of lithium dropped into water and I could capture the hydrogen gas. I'm not actually going to do that because lithium's pretty expensive, and I don't like. I'd rather have maybe a cheaper or a different way, because you've already seen that. Let's do a different way of producing hydrogen gas. So we're going to produce hydrogen gas. Would you say that's a pretty good gas to get the job done? Mm-hmm. Hydrogen gas is flammable and explosive, so we want to be able to produce it, but we want to do it safely. Now, I think the safest way to do it would probably be electrolysis, which means you put electricity through the water and then you bubble off the oxygen and the hydrogen gas. But I don't have an electrolysis machine that will give me enough hydrogen gas. I'd like to build one soon, but I don't have one yet. So let's do something different. So what I'm going to do is a reaction, and I'm going to take sodium hydroxide, which I made sure to have plenty. So sodium hydroxide is well, in this case, it's not in a solution form. So it's not already mixed with water pretty much. It's by itself. It's a solid, white, flaky, solid substance. And just to read the facts on this, it says it causes severe skin burns and eye damage. Do not breathe dust. Wear protective gloves and eye protection. Wash thoroughly after handling. So I already got my gloves on. I need to get my eye protection on too, especially once the reaction starts. So I got some eye protection on, and then also the lab coat should cover up most of my skin, so that just in case any of it splashes out, I'm good to go. And you guys will be safe from where you are. I'm just want to make sure I'm safe. Okay, so I got this on, and we actually see the series of reactions that I'm going to do up here. So look at number 1 first. So you see this sodium hydroxide right here. So I'm going to mix that's this right here. I'm going to mix it with water first. All right, so then let me just replace that 2 there. So H2O. And then I'm going to take, let me get blue. I'm going to take some aluminum, and then we're going to add those 2 things together. So I guess you could think about this as pretty much ingredient number 1, and this is pretty much together ingredient number 2. And then we can then see that we're producing some hydrogen gas, is what I care about. Let me do that in red over here. So this is really what I care about. This is my gas that's explosive. So that's the first step. Let's start there. So we're going to focus on the first reaction here. We're going to take some aluminum foil. So aluminum foil is a great source of aluminum. And I am first going to make it in just a beaker. So let's take some of my sodium hydroxide. My aluminum foil doesn't really need to be mixed with anything. And then I'm going to pour it right out of this container. If any of it spills, it's not a big deal, because I can just pick it up off the table. But I'm not going to go ahead and add it back into the container once it comes out, because I don't want to contaminate the original container. So that should be plenty. I'm not going to be super scientific about this, because all I want is a very strong solution of sodium hydroxide. And by the way, sodium hydroxide, which is this, NaOH, in water it's going to separate to be NaOH minus and Na plus. This is where you get a very strong base from. So the hydroxide ion is going to pretty much make it a super basic solution. Have you heard of like pH, acids and bases, right? So what I'm going to do, I'm going to use some pure water over here. It's not perfectly pure, but it's definitely distilled so that it's a lot more pure than what you would get out of your tap. All right, so we're going to stir it. And as I stir it, I'm feeling it because I know that it's actually going to release some heat. So certain chemicals, when you dissolve them in water, actually just the process of dissolving them in water will absorb or release energy, endothermic or exothermic. So this seems to be an exothermic process that I'm doing right now because it's very hot. Like it's right about now, I can't touch it anymore because it's going to burn me. And I value my skin cells. Okay, at least the ones that are living. So that is a pretty strong, I'm not going to go ahead and tell you exactly what molar concentration that is because I have no idea, but it's very strong. So it's a pretty strong solution of sodium hydroxide that I just dissolved in there, and it's pretty hot. So now what I need to do is go and get a different kind of flask, because how do you think I'm going to capture the gas when it's being produced? I have not started the reaction yet. How do you think I'm going to capture it? What's one way that I could capture it? Because I want to be able to capture it and then put it inside of the pumpkin. So how would I go about doing that? So I'm going to, let me show you what I'm going to do. First I'm going to pour this in here, and then I'm going to put some aluminum foil in there. But the second I put aluminum foil in there, it's going to start producing, that reaction there, and I'm going to start collecting my gas. So how am I going to collect the gas as it's being produced? What is it? A balloon, sure. It's a great way. Or maybe a water bottle or something, but a balloon is really good because it makes a tight seal over the top. So I can just do this, and hopefully, boom, right there, that's a tight seal. And if I really wanted to, I could probably put the chunks of aluminum foil inside of the balloon, and then I could have it like this, and then I could drop it in. So I kind of want to try that, but I also don't want it to get stuck in there. And so what we're going to do instead is I'll probably have a volunteer help me, because I don't have 3 hands. Who wants to help me? You want to help me, Bobby? Okay. So you're going to need to get some gloves from over there real quick, just in case, and some safety goggles, which yeah, sure. Okay, so just in case, because there is a chance that when I put the aluminum foil, so let's get some aluminum foil, there's a chance that when it starts reacting, it'll react violently enough that it will potentially bubble up and spray some like aluminum foil that's still reacting onto your skin. So you don't want that. So you got all your skin covered up and you're ready to go. So what Bobby's going to do is I'm just going to get some aluminum foil like this. I want to increase my surface area of my aluminum foil, so I'm not going to like ball it up into like a tight ball. I'm going to kind of leave it as like flakes of aluminum. It's going to react faster that way. And pretty much, I'm going to have all the hydrogen I need definitely within 10 seconds. So it's going to be a fast process, all right? So do you want to actually go around to the front? I think that'll maybe be easier. And then to stand here, and then that way we're not kind of competing with each other. So I think that's probably enough aluminum. Maybe we'll use just a little bit more. So we're going to put aluminum in there, and then the other thing that I know about this reaction that's about to happen, reaction number 1, is that it's going to release a whole bunch of energy. It's going to release so much energy that the glass is going to get so hot where I will burn myself severely if I'm holding on to this glass. So I'm going to need to grab a glove. So let me grab a thermally insulated glove. So I'm going to wear one thermally insulated glove. So this is super safety, right? So I have one thermally insulated glove, and then my other one I need dexterity, like I need to be able to manipulate this balloon, so I'm going to need to maintain some of my dexterity here. So it's going to be quite interesting doing this. So let me get this balloon started. All right, you ready? So then you take up all that aluminum foil, you can crush it a little bit, and then we're going to put that aluminum foil into here, and all at once, and you're going to do as quick as you can, and then you're going to back away. And then I am going to put the balloon on top, and I'm going to capture as much gas as I can. You ready? Right. Well, wait. Separate it a little bit. I don't want like a big ball, because the big ball is going to take a longer time to react. So I want to expose more surface area. All right. Okay, you ready? That should be better. Yeah, because if you get a big ball, only outside reacts. All right, here we go. Go ahead. Get that other piece in there. Okay. So I'm going to hold it with this hand because it's going to get hot. So my thermally insulated hand is holding it. I'm producing my hydrogen gas. I can't feel the heat, but I know it's hot. And then I can feel the heat now. It's very hot. Okay, that should be good enough. So I'm going to go ahead and pinch that off. Okay, now all that additional reaction is going up into the vent. So you can back off, and I think we're good now. Alrighty. So now I'm going to take this balloon of hydrogen gas and tie it off. And then I have myself a balloon of hydrogen gas. Now remember, the same thing applies to when the last time I produced hydrogen gas. If I get too close, yeah, you start to feel like you're drowning. So, and so I don't really want to inhale that very much. And so that's why you either do it in a fume hood or you have the ventilation system sucking it up. Pretty powerful, and we're actually pretty lucky to have a good ventilation system in this school. Okay, I'm listening for any leaks. I think it's good. Okay, so now if this was pure hydrogen, which it's not, there's contamination in here. But if it was pure hydrogen and you had enough of it, then it would float, wouldn't it? Just like helium. Hydrogen's actually like lighter than helium, isn't it? So it should be floating into the air right now, but it's not, and so that's because it's not pure. So hopefully we have enough hydrogen though in here, theoretically, where we can now blow up the pumpkin. How am I going to do that? Well, I'm going to put it into the pumpkin, and then I'm going to come in from the back with this little hole, and then I'm going to hopefully start that reaction with the hydrogen gas. So let's do it. And then I'll take this, which is, it's good now. It's cooled down enough where I'm going to put it over in the fume hood. All right, and then get everything else out of the way that could cause an issue. And then we will start another reaction. Now I am going to use another glove here because this is going to produce flames probably, and flames can shoot out of that hole at me, so I want to make sure my hand's protected. So I'm going to start the reaction number 2 now between methane and oxygen. So methane gas coming out of here, oxygen gas, and then this is my reaction that we've all seen before that I'm going to do right here. So this is that flamethrower, and I'm going to get it down to like here. So I have my mechanism of starting the other reaction, reaction number 3 that I care about. So reaction number 3, we're taking the hydrogen that we produced up there and we're reacting it with oxygen to produce water, which doesn't sound very dangerous, but it's very explosive. So, all right, so for this one you might want to get back further. I will warn you that there will probably be pieces of pumpkin flying. Like there will be, if it works properly. There will be pieces of this pumpkin that are flying through the room. So be prepared to be hit by a piece of pumpkin.
Okay.
But worst case scenario is you get hit with a piece of pumpkin. Doesn't sound that bad, right? Okay. So, and you guys are all far enough away. So let me move this over. Now, hopefully, this works pretty well here. So I'm going to insert flame, which is reacting with oxygen. My hope is that when I put it in there, it's not going to just go out before it's able to do what it's supposed to do. So, you ready? Let's try it. Did it. Yes.
I carved the pumpkin. That's so freaking cool.
Yes. So, did you notice that I carved the pumpkin ahead of time?
Yes.
And I did it specifically so that its nose, eyes, and mouth would shoot at you. Isn't that awesome? All right, so I need you to find the eyes and the nose.
Wait, what is the mouth and the nose?
The inside is just, I didn't bother taking the guts out, so the inside is just a bunch of guts and it's that balloon in there. You can look in there if you want. Okay, so I have, oh no, I think I broke the mouth. No, I'm good. Look at, the mouth is good. It's intact. Look at that. There you go, buddy. All right, there's the nose. Looks like the eye is officially cracked now. So we'll just pretend that didn't happen. Sorry,
Time for me to take
Here,
screenshots.
We'll just do this,
Oh,
and then he'll be crying, and that will disguise the crack there. Okay, I need eyeballs.
Maybe make it symmetrical tears. Just so.
Eyeballs. Okay, good. So we are good to go. So that pumpkin now is a great example of how you can take some awesome science of, you know, reactions like this, where you have explosions and exciting stuff happening in the classroom where it's kind of safe, right? I mean, it didn't I didn't die, and nobody got hurt, so I guess that's a plus, right?
I
So
got hit in the face with that mouth.
it would have been interesting if somebody got hit in the mouth with the mouth. So, but that has not happened yet, and luckily the camera did not get hit by the mouth, because that would have been kind of cool to look back at the footage of that. But that is an expensive camera, so I don't want to break it. Anyway, guys, any questions on this? You have fun? All right.
Yeah.
So let's move on to the next thing of the day.